Alright guys, so welcome to lesson 6, last lesson of the year. We were talking about states of matter, right? So we've gone through gases, liquids, and solids, and now we're going to sort of wrap that up and talk about something called phase diagrams, which is super important because just recently I also had students that I've had in the past that are now in college level chemistry message me about these phase diagrams, and they needed some help reading them. So we're going to take a look at them, what phase diagrams have to offer a little bit, and what they mean for scientists and how we report like the phases of matter and the states of matter. So after today, you should be able to draw a phase diagram and label each state of matter, change of state, and the triple point. And I'm going to show you how to do that, and that should be labeled all in your notes. We're going to go over that. We're going to identify at what temperature or pressure a substance will change state at. We're going to identify which state is the most or least dense form and the normal boiling point and the NFP as well. So a phase diagram. A phase diagram shows the conditions of the temperature and pressure that are necessary for a substance to exist as a solid, liquid, or gas. So it's all about temperature and pressure, right? If we increase pressure, we're going to move more towards a solid state. If we're increasing temperature, maybe we're melting that solid into a liquid or making that liquid evaporate into a gas. So temperature and pressure are really important for these phase diagrams. So let's take a look. If you're looking at your notes and you're also looking at my PowerPoint, this probably looks super confusing, but we're going to go ahead and go over this. So let's take a look at the left-hand side at the y-axis. We have pressure in kilopascals. And you might notice that number 101.3, that is the standard pressure in kilopascals. So we have that labeled up there for you. And on the other axis, on our x-axis, we have temperature reported in degrees Celsius. Okay, we have a couple of things at the bottom. Take a look at those little blue arrows pointing to those dotted lines. The dotted line on the left, starting on the x-axis and going up, that represents the normal melting point at 0 degrees Celsius. And the dotted line on the right, that represents the normal boiling point at 100 degrees Celsius. So typically in Celsius, solids melt at 0 degrees Celsius and they boil at 100 degrees Celsius. So that's sort of what those lines are telling you, and it goes up to meet that 101.3 kilopascal pressure. So let's start over to the left. We see that big bold word, we see solid, and underneath solid we see sublimation / deposition. So this is the area, right, low pressure and low temperature, where we're going to have solids going straight to gas and gas going straight back to solids. So this is what's happening right there, sublimation and deposition. If you increase the temperature and pressure just a little bit, you'll see that little red dot called the triple point. The triple point's actually pretty unique. That's when a solid, liquid, and a gas exists all at the same time. We're going to take a look at a picture with that in just a second. Okay, staying at that temperature basically and moving upward to that line that says melting / freezing, right, we still have a relatively low temperature, but we're adding a bunch more pressure, so it's going to condense those liquid molecules and make them freeze. And going up to that line that says boiling and condensing, we're really increasing the temperature, getting over to the right over there, and we're adding a lot of pressure too. So we can boil something. We can also condense something and make it back into a solid by adding that really high pressure. So kind of confusing. We're going to dive a little bit more into it. You don't have to be a master at this, but just so you sort of get a feel of what a phase diagram looks like. Okay. So let's take a look at the triple point. That triple point was that little dot on the graph up there, that little red dot right there. So the triple point is the conditions of the temperature and pressure where all three states of matter are in equilibrium. So solid, liquid, and gas can exist simultaneously. So this is actually the triple point of water. It's a little bit hard to see the gas trapped in there in the top of that flask, but you can also see the liquid and the solid, the crystalline solid forming right at the top. So all three of them are sort of existing in equilibrium or in harmony at the triple point. So there's two types of phase diagrams. We have the liquid state is more dense than the solid state, and we have one where the solid state is more dense than the liquid state. So we're going to take a look at those. Okay, so take a look at this phase diagram. The line between the solid and the liquid, which is called the solid-liquid line, slants to the left, and it's going to make that liquid section bigger in area than the solid section. And so if you have a bigger area in the liquid section, that little V shape right there, that means that the liquid is more dense and the solid is less dense. That's why for water, the solid form, which is ice, floats. It is less dense. For most substances, however, our phase diagram is going to look like this, where the solid phase is has a much bigger area than the liquid phase, and the solid-liquid line is slanting to the right. So if the solid area is more or has more area than the liquid, then that means the solid is more dense. So the solid's going to sink. Okay, so these are probably the most important ones, right? Knowing this entire thing, I'm not super concerned about. You do need to answer a couple of questions about this. However, the most important thing to take away from these when reading phase diagrams is if that solid liquid line between the solid and liquid areas is over to the left and the liquid section is much bigger, that's the one that's more dense. If the solid liquid line is slanted over to the right and the solid area is much bigger, that's the one that's more dense. Alright, so that is the last lesson for chemistry this year. So go ahead and make sure to ask me any questions on Teams. Go ahead and get that homework done. You also have another quiz coming up. It should be pretty easy. And then that is the end of the class. So last lesson. Alright, so like I said, any questions, let me know. Good job, guys. Hang in there. We're almost to summer.